This video will discuss how we add and subtract complex numbers. And adding complex numbers are going to be the same thing that we do when we add like terms. If we have, for instance, a plus bi, and we want to add to this c plus di, well, we're going to combine the real parts to get a plus c, and we're going to combine the imaginary parts, b plus d, and we're going to multiply that by I. So essentially we're going to add the real parts and add the coefficients, if you will, on I. Subtracting is quite the same. A plus bi minus c plus di. We have to be careful here to distribute that negative, but we end up with a minus c plus b minus d times I. Now let's try an example. Again, we want to add our like terms, our real parts here. 5 and 7 would give us 12, and then we have negative 3i plus 2i would give us a negative 1i. Or we can simply just write this as 12 minus I. If we have multiple terms here, again, we just combine the like ones. 7 plus 8 is 15, plus negative 1 is 14. And we have negative 1 plus 3 would be 2, 2 plus 6 would be 8i. Subtraction, again, we just have to make sure we're careful here. I'm going to rewrite this as 4 plus 9i minus 2 plus 7i so that we distribute that negative. And this comes out to be 4 minus 2 would be 2, 9 plus 7 would be 16i. We have more than one. Again, we just need to be careful with distributing that negative. Negative 3 plus 8i minus 6 plus 8i is how that one's going to change. And then minus 1 minus 5i. So again, we combine the like terms. Negative 3 and negative 6 is negative 9. And a negative 1 is going to give us negative 10. 8 plus 8 is 16. Minus 5 would give us 11i. So I want you to pause the video now and try example 7. So for example 7, you should have come up with negative 4 plus 28i. Addition and subtraction is pretty straightforward. Multiplication is also straightforward. In this case, we are simply going to go through the process that we learned in algebra, which we usually refer to as FOILing or distributing. In this case, we are going to multiply our first terms. So we have 3 times 5 is 15. And then we will take the 3 times the negative 9 to get negative 27i. And then we will take the 8 times the 5 to get 40i. And finally, we will take the 8i times negative 9i to get negative 72i squared. Be careful there, that's I squared. Now when we simplify, we have 15 minus 27 plus 40 would give us a positive 13i, and this is where we need to be careful. This negative 72 is multiplied by I squared, and we said that I squared was negative 1. So essentially this is positive 72. So we have 15 plus 13i plus 72, so now those real parts can be combined to get 87 plus 13i. We'll try another example here. In this case, the first terms multiply to give us negative 20. The negative 4 times negative 3 would give us positive 12i. The inner pieces would give us a positive 35i. And the last terms, the I terms, would give us a negative 21i squared. Now we already said that this I squared is going to change the sign here because we're multiplying by negative 1. So we end up with negative 20 plus 21, which is 1. And 12 plus 35 would give us 47i. Now I want you to pause the video and try example 10. So when all is said and done with this one, we end up with simply 97. And I realize that 4 plus 9i times 4 minus 9i is probably the strangest way you've ever seen 97 written. But this is what the answer comes up to be. This is a real answer. And these two numbers that we use, these two complex numbers, have a special name, which is a conjugate. And that is going to be helpful when we start talking about division. So a conjugate, if we have a complex number a plus bi, then its conjugate is a minus bi. So we change the sign on that imaginary term. And they always have the property that if we multiply these together, a plus bi times a minus bi, then we'll end up with a squared minus abi plus abi minus b squared I squared. And again, we said that I squared was -1, so that will change that sign. The positive and negative abi will cancel to be 0, and we're simply left with a squared plus b squared. And this is going to be what's necessary to do division. For division, what we are going to do is we are going to multiply the top and the bottom by the conjugate of the denominator. So first things first, we will put in our parentheses, and then we will multiply by the conjugate of 4 plus I. So this is 4 minus I. And we will multiply the top and the bottom by this. So we're just going to repeat the process that we had for multiplication. We're going to distribute. We end up with 8 minus 2i minus 12i and plus 3i squared. In the denominator, you end up with 16 minus 4i plus 4i and minus I squared. So when we go to simplify, again, the I squareds change the sign. And we end up with 8 minus 3 would be 5. And then you have a negative 14i over 16 plus 1 is 17. And this is how we divide. We end up with a number like this, or we could write it as, we can split this up since we have one number in the denominator, 5/17 minus 14/17 I, if we wanted to write it in rectangular form. Now I want you to pause the video and try example 12. So for example 12, you should have found that you either end up with 44 minus 57i all over 85, or if you split that up to write it in rectangular form, 44 85ths minus 57 85ths I. We're going to do one more example here together. And again, in this case, we're going to multiply by 9 plus I on the top and the bottom because that is the conjugate. So when we distribute here, we get negative 27i minus 3i squared. We only have one term to distribute. And in the bottom, we end up with 81 plus 9i minus 9i and minus I squared. So again, these I squared change the sign. You end up with a plus 1 in the denominator. So you're left with 3 minus 27i over 81 plus 1 would be 82. And again, if you want to write this in complex form, this would be 3 82nds minus 27 82nds times I. Either one of these answers is acceptable. This concludes the second part of the video for section 14.1. The last video will discuss how to solve quadratic equations that involve complex roots and also talk about graphing these complex numbers.